now we are going to discuss about random forest algorithm. So this random forest algorithm is another machine learning algorithm which is used to make a classifier. So the random forest algorithm can use both for classification and the regression kind of problem. So when we are thinking about random forest, what is this random forest? So how it's applicable for both classification and regression? So this random forest is applicable from our decision tree. So where we already discussed about the decision tree, so now we are just going to start with our random forest. So generally what is known as forest? The forest that is nothing but a number of trees. So that's what our forest is. So here this random forest, that's nothing but the number of trees from our decision tree. So this is used to robust the forest looks like that. So the same way random forest classifier, the higher number of trees in the forest gives the high accuracy. So when the trees increase, the accuracy also gets increased. So if you know the decision tree algorithm, you might be thinking that we are creating a more number of decision tree and how we are going to create more number of decision trees. So the calculation of node, we need to do it in same way. So when you are going ahead with random forest, this random forest that is nothing but decision tree subset. So this random forest is actually operates to construct a multiple decisions. So for example, now we have a decision tree 1. This is one tree for example. So this tree output we are getting an apple. So then we are having another thing that's nothing but another tree, and this tree apple is orange. And then we are having another tree, and this tree output is again apple. So now this random forest, so this is known as your random forest, and this random forest will collect the output from your different decision trees. This is how it looks like. So this is one tree and this is another tree. So one tree and another tree, and from n number of tree it will collect the result and it will apply those results to the random forest. So the majority votes, it will take the final decision. So where you have one group of basket, that basket which is having apple and orange, and now you are going to give one input as an apple. So now you are going to give the input that we don't know, it is considered as an apple now. So this input we need to know about either it's an apple or orange. So to identify this, we are applying the random forest. So in the random forest, first it will create one tree node. So we are getting an apple. So another tree node we are getting that as an orange, and another tree node we are getting that as an apple. And all these three trees we are applying in our random forest. So what is the majority vote? So here our output is 2 apple and here our output is 1 orange. So the majority votes, it comes for apples. So I decided the input which given by user is apple. So how the decision tree work? See, the decision tree is a tree which each and every branch, that's nothing but we are just going to calculate the particular decision. So any one condition you are going to apply in your decision tree. So let's see how the decision tree works is. So how the decision tree works is, so when you are having something like a basket like this, so in this basket you have something like apple and another apple, and we have a cherry and we having another apple, so we having an orange, we have a multiple fruits in this basket. So now what I am just going to do is, based on the diameter, I am planning to split this. So when I am just choosing the diameter, for example less than or equal to 3, I am just making all those things. Maybe cherry will be less than or equal to 3, is less than 3 in diameter. But apple, orange, banana, everything will be more than 3. So more than 3, what I am just going to given, it comes under this loop. So here we having another apple and orange, and here we are having banana. We have a multiple fruits in this. So now again I am applying with the color. So in this color I am just going to calculate the apple. So apple is in red color and orange is in an orange color. So if the color is red, so we are just making this an apple, and if the color is orange, then we are then making as an orange. So this is how one tree works. So when we are going to apply this thing towards our random forest, we are just going to choose a multiple ways. So this is one node which is based on one diameter, and another thing based on the height, the another thing based on the shape, and another thing based on the weight. So each and every tree, where you have a tree 1 and where you have a tree 2 and where you having a tree 3, each and every tree which different conditions, it starts to work. So this decision tree, it's nothing but based on only one. It may be a diameter. So now the another decision tree based on shape. The another decision tree based on height. So now I am creating a different trees and I am just making one output. That's what our decision tree output is. So what are the use cases of our decision tree? So this decision tree which is used in your ETM device. So what is this ETM device? So this ETM device, that is nothing but which is used in satellites. So when we want to see the human spectrum from the land masses and acquiring the images of the earth's surface. So for this perspective, the ETM devices is used. And then object detection. So when it's an object, I want to detect either it's a car or bus or bike or a cycle. So for this kind of object detection, we are using our random forest. Then Kinect. So we are using the random forest in Kinect. That's nothing but a game console. So which is used to track the body movement and recreating in our game. So when in this kind of thing, so it's a kindly full of visualization stuff. So first we are training the body. So training the body, we are just making a leg like this and the hand like this. So this may be we are just training. So on the body parts, head like this, and then we are just making a chest like this. So everything we are making like this. So once we make this, we are applying here the random forest classifier to make our machines to learn about the body parts. So when we are just moving it based on our body moving, or when you are dancing it, so your accuracy of your game will be increased based on this movement. So this is how our random forest will work. So the random forest is actually used in the different kind of machine learning. One is reinforced, another one is unsupervised, and another one is supervised. So when it comes to reinforced, that's nothing but this is the process of teaching a machine to make a specific decision using a trial and errors. Unsupervised, we don't know about the target, but still we are going to predict something. That's what unsupervised. Supervised is nothing but we know about the target and we are just going to predict that. That's what our supervised is. So why we need to use a random forest? So this random forest, the main advantage is the decision tree, it's overcoming the decision tree disadvantage. That's nothing but the risk of overfitting, random forest overcomes. So random forest runs efficiently the large database and produce the highly accurate predicting by estimating the missing data. So what are the terms that we need to know? We need to know about entropy, that's we already discussed on our decision tree, and then we need to know about information gain, and we need to know about leaf node, decision node, and we need to know about each and everything. So that's what our decision tree is. So we need to classify some features. So for example, when I am just giving you the fruits, Now in the fruits, we are just going to cluster with the different options. So you would create a training data set that which contains the information about the fruits, including the specs, colors, diameter, everything, and we need to split the thing based on the different condition. So when you are planning to choose these fruits, let's see what are the kind of conditions we may choose. So now we are going to apply the different conditions. So what are the conditions? So condition may be based on your color, and then based on our diameter, and based on our color again. It's equal to yellow or orange, and then again based on the color it's equal to red, and again based on the diameter is it equal to 1 or less than or equal to 1, like this. So based on this, we are just going to build our random forest. So for our fruit bowl example. So this is how our random forest work in our algorithms. So now our next example is we need to apply this random forest towards our Python to get to know the more in-depth about our algorithms. So how to apply this random forest with our Python. So now we are going to read one data set. The data set, that's nothing but a breast cancer using a patient treatment, and this is the history which is gathered. So now this data set is available in Kaggle and UCI everywhere. So now we are going to create and visualize the random forest classification model in machine learning by using Python. So how we are going to do this, that's nothing but first step, we are going to import the pandas as like same as everywhere. So read underscore then CSV. So pandas dot read underscore CSV. So I saved the CSV file as a data, and then like data set dot head, we are just getting the data set. So now we are just having this data set where we have almost the 33 columns. So each and every columns which is used to define different futures. So now we need to make our x and y. Now we are simply going to make our futures from the target. So I thought of going from this radius mean, and then texture mean, and then perimeter mean, and then area mean. I want only this 4 thing which is more than enough for me. So I am planning to get only this 4 thing as my data frame. So now I am going to create my futures. So I am planning to get only the sum of the things from my data frame. So which is, we are going to create the futures. So now x, the variable name, pandas dot data frame, I am going to give data set dot index locate. We are going to get all the rows, comma. So now I want to get this radius mean, texture mean, perimeter mean, and area mean, only these 4 columns. So for that perspective, what I am just doing is we are applying the slicing. So this is starting from 2, so 0, 1, 2, so 3, 4, 5. So this area mean is 5, so we need to give 6 because always the last value excludes. Great, we run this. So now x dot head, we are just going to get the sample. Great, whatever we needed, we just got it. So now from this 33 columns, I want one more column as my diagnostic. So first we need to get to know where the diagnostic column is there, because somewhere here we are having this column. So now we need to get to know the diagnostic column is there or not. If diagnosis is not there, then we need to find the target, but definitely the diagnosis will be there. So to getting the column name, we just apply dataset.column. So we got all the column names. Oh great, here we are having a diagnosis. I just missed that. So here we have a diagnosis. So now the diagnosis is my actual target. So I am just going to create my y here. So the y again pandas dot data frame. So what we are going to create here is from the dataset dot index locate for all rows. So this is our first column, right? So I need to give 1. Great. So let's check y dot head. Wow, we got the diagnosis column as our y value. So now we need to split the data set into training and testing. So for that perspective, as usual, we are going to import our training and testing from our scientific kitland model selection. So from our scientific kitland, from our model selection, I am just going to import my train underscore test underscore split. Then we are going to create a 4 variables, xtrain and then xtest and then ytrain and then ytest. Great, we just created this. Now we are applying train underscore test underscore split in our x and y data set, and I am just planning to give test size as 0.2. So total we are giving 20% of the data of our test size. Here x is small x. Great. So now it's getting run. So after it's done, we need to apply the random classifier function from our scientific land ensemble module. So build the random forest classifier model, we need to apply the classifier function. So that's actually available with our data scientific kitland. So where we are already having our training and testing split, now I am just going to import the scientific land ensemble is another method is available. We are just importing the random forest classifier. So after that we are just applying one variable name. So along with this variable name, we are creating a random forest classifier function. So now we need to tell 3 parameters. So the parameters are nothing but, first I need to tell how many trees I want. So I am giving n estimators. So this is nothing but how many trees, and I am giving the criteria. So this criterion which we are giving in the Gini index. So after that we need to apply our random state. Because here why we are applying a random state is every time we need to get the same thing, like our indexing slicing concept only. And then max depth, that's nothing but how much depth it wants to go ahead with this data set. So now we are just running that, so it's going for. So after this we build our machine learning model. Now we need to predict the values. So I am just giving y variable name and then classifier, that's nothing but my variable name which we build the model, and then we are just applying the predict. So this predict we are going to apply with our test. So why we are getting an error, that's nothing but I gave underscore. So x test is not defined, x is the caps, not fitted error. Oh my god, this random forest instance not fitted at fit. Okay. So actually we apply the predict without applying the fit model, that's a problem. Okay, we need to first apply the fit. So I am just applying the fit model. So we need to fit our random forest along with our training and our x train and y train. So object has no attribute. Yeah. So now our random forest model is built. Now we predicted the output. Now we need to apply the evaluation function here. So what I am just going to do is, from our scikit-learn matrix, I am just importing my classification report, and then I am just giving my confusion matrix, and then I am just giving my accuracy. So after this, I am just going to print my confusion matrix for my y text and y prediction. So y text and y prediction. So after this, I am going to print my classification report for again for our y text and my y prediction. For the same variable only we are just going to predict, and then again what we are going to predict, that is nothing but our accuracy score. So accuracy underscore score, we are going to give our testing, and we are going to give our prediction. So when we are just running, yeah, so we are, and today making mistakes, so we are not having the thing, oh my god. So here what mistake I am making here is accuracy underscore score. So here, so it's all careless mistakes. So y underscore prediction, so as like y underscore prediction output. Oh god, finally we got the output, except we are getting only one error, that's nothing but this is not defined error. Great. Oh my god, they are getting the accuracy of 90%. It's a pretty good accuracy. So with the help of scikit-learn, we can able to select our features which is used to build the random forest. So we can able to apply our select from model, which allows us to get the threshold value as well. So this all the things which is applicable in our random forest. Now we are getting a very good result. So now the next step here is we need to visualize the result. If you want to visualize the result, we can able to apply our visualization technologies by using our select from model, which is used to get how many estimators and how many things which is applied, and then we can able to get the transform method to get the important features which is applied in our training and testing. So after this we can able to get, we can go and apply little more the high level of random forest. So it will lead us to get some more accuracy. After our future selection process, if the accuracy score is decreased, we have successfully picked out the important features at the small cost of accuracy. So this automatic feature selection reduces the complexity of the model, but does not necessarily increase the accuracy. In order to get our desired accuracy, we need to perform the feature selection process manually. So in this random forest, we just learn what is random forest and how to apply the random forest. So our next thing we are just going to cover about what is the difference between each and every algorithms.